Okay, for those teenagers who take the written driving test, only 75% have actually studied for it. Of those who study for the test, 80% pass. Of those who do not study for the test, 30% pass. All right, the thing about these tree diagrams, I have a partially completed one here, but each of these branchings here, each of these branches represents a complement. So, for instance, if 75% of the students study, or 75% of the teenagers studied, then by default, 25% of them, or the complement, 100% minus 75%, do not study. So this would be the probability that a student did not study, the complement. Same here for part B there. If 80% of those who studied passed the exam, that would mean that 20% or 100% minus 80%, 20% failed or did not pass who studied. So given that somebody studied, given that they studied, the probability that they did not pass, the complement of passing, is equal to 20%. 20%, because these have to add up to 100. These have to add up to 100. And this one, by the way, is the probability that somebody passed given that they studied. So that's why they're the complements. This is the probability of passing given you studied. This is the probability of not passing given you studied. But we're both on the studied branch. Okay, the next one. Well, it says 30% of them that did not study passed. So this is the probability of passing given that you did not study, the complement of studying. And then down here we're going to do the probability of not passing given that you did not study. And that's equal to the complement of this one. So since that's 30%, this one has to be the complement, 100% minus 30%, 70%. So that's how you fill out these first couple here. A, the probability that the student did not study is 25. B, the probability that they did not pass given that they studied is 20%. And C, the probability that they did not pass given that they did not study is 70%. All right, that's how you fill those out. Now, for part B here, lowercase b, we have find the decimal probability for all four of these outcomes. And these are joint probabilities here, joint probabilities. So we're looking for joint probabilities. Now, given what we have in this table, we can actually find the joint probabilities rather easily. To find the joint probabilities from this table, we pretty much have to remember one thing. We have the conditional probabilities for all the events we're looking for, all four of them, and it turns out that a joint probability is just the conditional probability divided by the probability of, the joint probability is just the conditional probability times the probability of the other event. So for instance, if we're looking for the probability of studying and passing the test, that's equal to the probability of studying times the probability of passing the test given that you studied. And we have those pieces of information. We have the probability that somebody studied, and we have the probability that they passed given that they studied. Those two pieces of information are right here. This is the probability that somebody studied. So this is the probability that one of these teenagers studied. And this is the probability that they passed given that they studied. So that means that the joint probability of passing and studying is the product of those two. So it's just the product of those two. So 0.75 times 0.8 gives me a joint probability of passing and studying of 0.6. And they said to round to 4 decimal places, so it'll probably just take 0.6 though. So that one was straightforward, right? And it turns out these are all just the products of those previous two. So for instance, the probability of studying and not passing the test, the complement of passing, is equal to the probability of studying, which we already know we have, times the probability of not passing, given that you studied. And that's a piece of information we have. That's just this second branch right here. So that's 0.75 times 0.2, which is 0.15. So the probability of not passing and studying is 0.15. All right, and then the next one, let's see. That's the probability of not studying, did not study, and passing the test. Passing the test. So that's the probability of not studying times the probability of passing the test given that you did not study. And that's just that second branch down here, but the top branch of the second one. So passing given that you didn't study. So that's 0.25 times 0.3. 0.25 times 0.3 is 0.075. So this is the probability of passing, not studying and passing. Not studying and passing. And that's equal to 0.075. And last, the bottom one there is the probability of not studying and not passing. And that's equal to the probability of not studying times the probability of not studying given, or of not passing given that you didn't study. All right, and that's just that last branch. So 0.25 times 0.7, this is the probability of not studying and not passing, which is equal to 0.175. So there we filled out not only the conditionals in the tree diagram, but also the joint probabilities. And now we can finish this down here. Oh, actually, we just put those numbers in, right? 0.15, 0.075, 0.075, and 0.175. And then we can answer these last two parts here, C and D. It says, find the probability that a randomly selected teenager does not pass the driver's test. We're going to need special knowledge for this. We need to know that when we total all these probabilities, the probability, we're looking for the probability of not passing. We have the probability of not passing and studying. And we also have the probability of not passing and not studying. And if we add those two together, is the total probability of not passing. So the total probability of not passing is equal to, this is the probability of not passing, complement of passing. So the probability of not passing is equal to the sum of these two probabilities here. Is the probability of not passing and not studying, and the probability of not passing and studying. So that's 0.15 plus 0.175. I'm adding up E and G to get the answer for part C, because the total probability of not passing is those who passed or those who did not pass and studied, and those who did not pass and did not study. That's everybody who did not pass. So we add those two together, we get 0.15 and 0.175, which amounts to 0.325. 0.325 is just the sum of this and this. And the last thing we need to know, the last thing we're asked for is the probability that they studied, probability of studying, given that we know that they did not pass the test. Now, this is an inverted conditional, because all the conditionals we have, the passing part came first, and the condition was that they studied. In this case, the condition is about passing, and we're looking for a probability of studying. So it's an inversion. And in order to do that, we use Bayes' theorem, but really we have enough information right here to do it, because this is just the probability of studying and not passing divided by the probability of not passing, which we have all this information. For instance, the probability of studying and not passing, well, here it is right here. Probability of studying and not passing. So this is the probability of studying and not passing the test, 0.15, 0.15. And we also have the probability of not passing the test, which is the answer we just found. Probability of not passing the test is this, 0.325, 0.325. And when we find that quotient, we get the answer for this to be 0.4615. And that is the probability, the final answer here. So the Bayesian probability here, the inverted probability, is 46.15%.